Good morning, ladies and gentlemen. Very good job warming up for today. Let's see how we did as far as success. So equity bars are in effect. Let's see how we did. Which of the following have at least one zero greater than 4? I've got student number 4, student number 20, student number 15, student number 7, and student number 10. Student number 4, what did you get?
B, E,
B, E, and F. Student number 20.
B, C, E.
Okay. Student number 15.
E, F.
Okay. Student number 7.
E,
Student number 10. The correct answers are B, E, and F. So give me a thumbs up if you got that right. I already know 4 people who did. And Daniela, I'm going to ask you to go back. You said C, and I want you to go back and see if you can find your mistake. Good, you can put your thumbs down. So that's pretty darn outstanding. I'm actually incredibly impressed. Did anyone have any questions about approach or what was going on here? I mean, I walked around and it seemed like everyone knew what to do. I was incredibly impressed. Well, that's wonderful. Keep up the great work. I mean, I had earmarked time to go ahead and go over each one of these. Is there one in particular that anyone has questions on or anything at all? Outstanding. Well, let's pause here. So, what we have been doing for the past month and a half or so is actually building a toolbox. You are now equipped with a whole bunch of different tools to help you solve problems. The types of problems we've been arming ourselves with these tools for are quadratic equations, anything involving quadratics. So, the methods you know at this point are graphing, factoring, using square roots. Those are the 3 tools that you have. And factoring itself has a whole bunch of different ways of factoring, so that one tool actually has a whole bunch of sub-tools. You actually are armed with a whole lot. Graphing is not the most efficient tool, so we probably won't use that tool moving forward unless specifically asked. But the rest apply very often. You also learned last time, using square roots, that tool only works in a certain situation, when there's no middle term. When b is 0, you can use square roots very effectively. When b is anything else, then you're not going to be able to use that tool. So that's what I talked to you about last time regarding knowing when you can use the tool and when not. You need to know the difference between when you can use a hammer and when you need a screwdriver. You can't always use a hammer in place of a screwdriver and vice versa. Very often you can. So, we're going to add another tool to our toolbox today. In fact, this tool is probably the most powerful one in that it works in all situations. It works for all quadratics. However, it's complex and therefore lends itself to little mistakes. And so we are going to use it as a last resort. So we're going to spend today working on it. But after today, actually partway through the day, I'm going to allow you to choose a different method depending on the situation. And at that point, you need to decide, is there a better way to do it or not? Okay? That's going to come up much later. So what am I talking about? I'm talking about the quadratic formula. So the quadratic formula applies to quadratics written in this form. Because the formula is based on knowing A, B, and C. And you do not know what A and B and C are until it's written in standard form like this. Once you have it written in standard form like this, this is the formula. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. You're going to have to live it, love it, learn it. You're going to have to know it off the top of your head. There's a reason why I say it so rapidly. I'm trying to demonstrate to you how rapidly and how well you need to know it. Do I have to think about it? It's a tool that I can use at any time I want because I know it instantly. I don't have to Google it because I already know it. So if you and I are up for the same job and I'm sitting outside the CEO's office and I know that the way I'm going to get the job is by doing a quadratic formula, guess what? I'm getting the job and you're not. Now I know that's a little far-fetched, but my point still remains that it's about efficiency and effectiveness. So make a note card for yourself. On one side, write the quadratic formula. On the other side, write the actual formula. Start memorizing. I will hand out cards at the end of class if I should have extras. So today is all about learning where the little details come up and where the danger zones are. There's quite a few of them. Any questions so far? So let's jump right in and do it. And you're going to see, based on your experience, where the danger zones are. So we want to solve this quadratic. And we are going to use the quadratic formula. So to use it, everything in the quadratic has to be on one side and we need a 0 on the other. We also would like to keep the x squared term positive if possible. So right now it's positive, so I wouldn't want to move it to that side because if I moved it to that side it's going to turn negative. So rather than do that, we're going to pull this over to the left. So how do we accomplish that? That should be something you're so good at. Diane?
Add 6x.
Beautiful. We add 6x to both sides. No big deal at this point. Hold on a second. This will disappear and we get our 0. And now we need to put this in the right order. 4x squared plus 6x minus 7 equals 0. Now we can see what A, B, and C are. A is 4, B is positive 6, and C is negative 7. We need those three values and the formula, and we can find the solutions of this quadratic. Remember, the solutions are the x-intercepts. These are the locations where the graph crosses the x-axis. So without having to graph, we can actually find the solutions. So let's start out with the formula. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. I will point out some danger zones along the way. But first danger zone is if you leave out any part of the formula, of course, it's going to be wrong. If you leave out any one detail, the whole thing will be wrong. For example, if you forget this negative sign right there, the whole thing will be wrong. So now we take the values for A, B, and C and plug them in. And then we crank it out. Do not forget to put the x equals, because that's what we're doing. We're trying to find x values. X equals negative b, or the opposite of b. Negative 6 plus or minus the square root of, and make a big square root symbol. B squared, 6 squared, minus 4 times a, which is a 4, times c, which is a negative 7, The whole thing is divided by 2 times a, which is 4. The biggest danger zone is the place we have to start. This is the biggest danger zone right here, inside the radical. In fact, this part right here messes up people more than anything else, because people get confused on what's going on. That really says -4 times -7. And whatever the result of that is, we add it to 6 squared. So if you really wanted to, you could say it's going to be 36 plus the result of this. That confuses people, because students start doing minus and then negative, and then, oh wait, is it subtract a negative? Wait, what? Subtract it, negative it, what? Add it? I'm confused. Very simple. You're multiplying 3 numbers. The first one's a negative number. So cranking it out means you have to go step by step, because if you don't, you're going to miss something and you're going to get the whole thing wrong. And who wants to spend 5 minutes doing a whole bunch of work and get the whole thing wrong? We want to spend 5 minutes of work and feel great about it. So let's start with the -4 times -7. If you need to use your calculator, use a calculator. And so we're going to rewrite the whole thing. X equals -6 plus or minus the square root of. The whole thing is going to be over 8. But now we're going to fill in what's left. 6 squared is 36 plus whatever the result of this is. What was the result of -4 times -7? What'd you get, Ethan?
112.
It's 112. So it's 36 plus 112 because it turned positive. Will it always turn positive? No. Sometimes it will be negative. Continue to crank it out. So now we need to do 36 plus 112. Well, that's not hard. What do we get? Deja? 148. Very good. So here's where we're at. X equals -6 plus or minus the square root of 148 over 8. 148, is that a perfect square? Could we just do it mentally, in other words? Like 25, we could take the square root of that easily. 148 a perfect square? It is not. 144 is a perfect square, 169 is a perfect square, 148 is not, so we need our calculator. So punch in 148 and hit the square root button, and round to the nearest hundredth. What do we get? Emily? 12.17. Sean, you agree with that? 12.17 over 8. Now, we need to deal with this symbol. That symbol actually means we're going to get 2 answers, as you learned last time. So we are going to branch off. We are going to branch off into 2 expressions. We are going to branch, actually 2 equations. We're going to branch off to x equals -6 plus, so we're going to use the plus over here, 12.17 divided by 8. And then over here, we're going to do x equals -6 minus 12.17 over 8. You have to simplify the top and then divide by 8. This is all calculator work at this point. So if you punch things in the calculator correctly, it's not a big deal. Your calculator should have a button that turns a number negative. So we have to put in a 6 and then turn it negative. I have a little plus minus symbol here. You might have a symbol that has an arrow from a plus to a minus. And in a few minutes, I'm going to give you the calculator's that we're going to be using for the EOC, and we'll use those as well. So I'm going to turn that negative, and now for the first one I'm going to add 12.17, hit the equal sign, push the equal sign, then divide by 8, push the equal sign again, and now we get our first value. X is going to be approximately 0.77. And then we're going to get another solution from the other equation. So now I have to clear out my calculator, and we're going to hit 6, turn it negative, subtract 12.17, hit the equal sign, and then divide by 8 again. This time we get negative 2.27 approximately. And so the two solutions are 0.77 and negative 2.27. So, know the formula, know what A, B, and C are, plug them in, crank it out. Watch for your danger zones. Biggest danger zone is right here. So, are there any questions on what to do? Because I'm going to have to do it by yourself. Any questions? Okay, so before I give you checkpoint number 1, other danger zones. Here's what's going to happen. Before you walk out of this room today, all of these things are going to happen. Someone will forget to take the square root. Someone will forget to divide by the denominator. Someone will put the wrong number in place of the wrong letter. Many people are going to miscalculate this. All of those things are going to happen. I don't want them to happen, but they're going to happen. Or maybe I'm wrong. Let's find out. Checkpoint number 1. Use the quadratic formula to solve this equation. I'm putting 5 minutes on the clock to see if you can work this in 5 minutes or less.
Yes, you. we'll maybe we got it. We'll see how we got it. So it's like it's x equals negative b plus minus square root of negative b. X equals It's that fast. If you look at that. So they're testing.
All right, let's see how we did. First attempt on your own. This should be interesting. I got student number 7, 11, 17, 18, and 9. Student number 7, what'd you get?
I got 1/2 or -3/4.
Student number 11.
Oh, okay, I'm sorry. I got x equals 0.5 and -3.
Okay, student number 17.
X equals 0.5 and 3.75.
Okay, student number 18.
I got x equals 1/2 and -3 and
Student number 9. Ew. The correct solutions are 0.5 or 1/2 and -3.75 or -3.5. So I want to take this opportunity to go over something. Here's the formula. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. I want to go over this little piece right here. No, I don't want that. Come on. Okay. Move this back. There we go. Okay, so let's talk about b squared minus 4ac. I want you to look at your papers. That's the part inside the radical. After you finish cranking out that part, what was the value? B squared minus 4ac. What did it come out to? Aaron?
1,156.
Give me a thumbs up if you agree that it was supposed to be 1,156. Okay? So good. Put your thumbs down. So this part was 1,156 after you finished all of this. Check your work. That's one of the keys. All right, so give me a thumbs up if you got this correct, the whole thing. Good. Now go back and look and find your mistake. Students who got it wrong. My students who got it wrong, find your mistake. What was the mistake? Melinda?
When I got those two values, instead of putting a plus sign, I left it as a negative.
So what did you end up with instead of 1,156?
196.
I think I said that was going to happen, didn't I?
Yeah.
Oh. It's like I have superpowers or something. Like, how did I know that was going to happen? It's amazing. Ethan, you said you had an error?
Yeah.
What was
I
it?
finished it, but I wrote down the wrong number.
Yeah, I didn't say that was going to happen. That's
Why, you know.
That's just like a simple thing we can fix. Who else found their error? Emily,
I put the wrong number for the
what did you put?
I put 6 instead of 46.
Oh. Is that just a copying error, or like
I
you just?
just wrote 6.
You wrote 6. Okay, well that's not, you didn't put the wrong number, you just misread the number, or you just was working too quickly. So that's not a big deal. Okay. Any comments or questions so far? All right, well let's fine tune this and let's make sure we're understanding what's happening here. This is not for you to copy, this is for us to go over as a group. So I said at the beginning of class that what I was doing with you was arming you with a toolbox. This is it. This is the toolbox. There's one tool in the toolbox that I have illustrated up here that you didn't learn yet. Someone tell me, which tool did you not learn yet? Natalie? You didn't learn completing the square yet. So we can take this out for now. This tool you do not have in your toolbox yet. But you have the rest. And you also have a good idea of when you could use them. For example, finding square roots. If you have the equation in this form, or if there's no middle term, in other words, b is 0, that method works great, and it's fast. If you can recognize that a quadratic can be factored easily, usually if a is 1, then you should factor. Graphing, spend a lot of time on it. It's really only useful if you just need an approximate solution, because sometimes it's hard to actually see where it crosses. And it's also a time-consuming process, so I'm not sure if that's the best approach. So what I'm thinking is that the best tools in our toolbox right now are factoring, finding square roots, and the quadratic formula. And it should probably happen in this order. You should probably check if this will work first, then check to see if that will work, and if that won't work, then try the quadratic formula. Also remember that factoring has lots of different ways of factoring. You can do GCF, you can do the special products, you can do unwrapping the foil, and you can use the trick. So this has 4 or 5 little methods within it. So this, in this table, there's a lot going on. Anyone have any questions? All right, so let's continue working. Find the x-intercepts. So you hear the phrase x-intercepts, what other words should you be thinking? X-intercepts, what words should you be thinking? Jen? Solution. Immediately your mind should go, okay, I'm looking for the solutions. So, if we wanted to, we could graph this. But that's no fun. So we're not going to graph it. It's also fraught with issues. It's very inaccurate, and it's hard to do. We could try to do square roots. Will square roots work with this? Give me a thumbs up if you think we could do square roots. Okay, someone explain why. Why can we not? Angela, why can we not?
There's a middle term.
You said that beautifully. What is the middle term?
3 negative x. No, 9x.
Yeah, this is the middle term, and that means we can't use square roots. Beautiful. So, what about factoring? Can we factor easily? Like, could you just do it really quickly? I couldn't do that quickly. Just by contrast, just to show you what I mean, this can be factored incredibly quickly. You should be able to look at that and go, oh yeah, that's easy. You should be able to do that. So that's what I mean by if you can recognize it quickly. But unfortunately, this one doesn't seem like you can factor it very easily. So where does that leave us? what tool should we use? Diane? Try the trick? We could absolutely try the trick. So we can't factor it easily, we could try the trick. We could do A times C is 16, and then find two numbers that multiply to 16 that add to negative 9. What are the numbers? What are the numbers? Come on, you can tell me. It's okay. I know. About negative 8 times negative 2. No, that doesn't work. How about negative 4 times negative 4? How about negative 16 times negative 1? Okay, we can't do it. So the trick doesn't work, which means we can't factor. So what tool are we at now? Oh, come on, you all know. What tool are we at now? You can say it. Say the scary word. Go ahead. The what? Really sounded very bizarre. The quadratic formula, of course. So, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Fill in the numbers and crank it out. X equals the opposite of b. b is negative 9. The opposite of that will be positive 9. Plus or minus the square root of b squared. Well, now that we know the formula and we're pretty bright students, we could do certain things mentally right away. For example, I know negative 9 squared is 81. So I don't have to write negative 9 squared. I can just write 81. This part I would not do mentally because you'll make a mistake somewhere. Minus 4 times A times C. All over 2A, and I can do this mentally. 2 times 2 is 4. So I've saved myself at least a little bit of effort. Start with this, being very careful. If x equals 9 plus or minus the square root of all over 4, what do we get when we do negative 4 times 2 times 8? Belinda?
Negative 64.
Good. So now add that to 81. What's the results? 81 and negative 64? Keon? We get 17. Now use your calculator. Take the square root of 17. Get x equals 9 plus or minus all over 4. What's the square root of 17 rounded to the nearest hundredth? Just got 4 people who can find the square root using the calculator and round it to the hundredths. Go ahead, Aaron. 4.12 approximately. 4.12. Any questions on how we got to this part? Any concerns? B squared negative 9 squared is 81. Did it mentally. Okay, so I apologize if that was a little too fast. So now we are ready to branch. Now we branch off to x equals 9 plus 4.12 divided by 4. And x equals 9 minus 4.12 divided by 4. Use your calculator. Go. You do it. Yes, Kianis, you got it? Hold on a second. People are still cranking it. Give me a thumbs up if you got two solutions. Okay, Kianis, what'd you get?
I got x equals 3.28 and 1.22.
Daniela, do you agree? Daniela, what was it? 3.28, 1.22 are the two solutions. Anyone disagree? I don't have the answers in front of me, so I'm not sure. Is that right? Good. Any questions on how we worked through this? Any concerns of any kind? Any issues of any kind? All right, checkpoint number 2. Find the x-intercepts of this.
That's 9, 9, or is that 99? Wait, how'd you observe that? Wait, I don't think that's one. I'm pretty sure I got that.
Mark, what's it again?
I got negative. I got negative 0. Negative
9.8. I got 9.9. Are you sure? 9.98, yes.
I guess I put this up. Both dots.
All right. We're back as a whole group. Glad to see you had a moment or two to share your answers with your teammates, but let's see what the correct answers are. So I've got student 16 is not here. Student 12, student 1, student 21, student 3, and student 18. Student number 12. Okay, student number 1.
X equals -9.98 and -0.0.
So I think that was the same thing that she said. Student number 21.
X equals -0.02
Okay, it was almost the same thing. Student number 3.
X equals -0.02, negative 9.98.
Okay, student 18.
X equals -0.02 and -9.98.
Wow, I got 5 people in the room. They got it right. That I know for certain. Everyone give me a thumbs up if you got it right. Put your thumbs down. My superpowers are dwindling. You guys are too good. Too good. Okay. That's all right. I'll be able to deal with it. All right. So now, application. So you do not need to copy the text of the question. You need to read the question, but you do need to draw the picture. Okay. Don't write the text of the question, just read it. And don't draw the picture, just look at it. And then let's work through this together. So I wasn't sure if everyone would know what a carnival strength test was, so I wanted to get a good picture for it. So this is one example. You may have been to a carnival that had this. The most recent one I went to was the Our Town Carnival in Coral Springs. They had a smaller one, much smaller than this. And so the idea is you have this heavy hammer, and you have to use your strength to hit this point. This is on a fulcrum, which means it's like a seesaw. It can tilt up and down. And there is sort of a heavy object on the end. And the objective is to try and get that object to go up and ring the bell. But it takes an incredible amount of strength to make it happen. So this metal object will only go based on the amount of force applied to the other end. So that's how the strength test works. It's an interesting little activity. And so what we have here in this scenario is what happened when one person raised the hammer and smacked it down. The metal object that goes up this scale is 2 feet off the ground. So it's 2 feet from the ground there. And its initial vertical velocity is 30 feet per second. The question is, will it reach 20 feet? So, you should instinctively already know that this is a vertical motion model, but I helped you out by putting my little poster over here. So the vertical motion model is h equals the height, the ending height, equals negative 16 t squared plus vt plus s. V is the initial vertical velocity, s is the starting height. So let's take some info from the text and fill it in. Go ahead, you do it. All right, student number 13, what'd you write?
20 equals negative 16t squared plus 30t plus.
Okay. Well, you did awesome so far. So let's put in what you said, because that was great. That was spot on. 20 is the ending height that we're checking. Equals negative 16t squared, always stays that, plus 30t plus, and he wasn't sure what to put there. That's okay. Anyone want to help out? What do you put? Deja? Where'd you get the 2 from? Yeah, that's the starting height. It's the 2 feet off the ground. Absolutely. So now to solve this, we have to have a 0 on one side and everything else on the other. So we need this 20 to disappear and end up over here. You already know what to do. Go ahead and do that. That's an easy step for you guys. So now we are trying to solve this puzzle. Will this person's metal object reach 20 feet? And we have this quadratic set up to do it. And we have a whole toolbox of tools at our disposal. What tool do you think we should try first? What tool should we try? Oh, by the way, not every job only uses one tool. Some jobs use multiple tools. Couldn't there be a situation where you would have to use a hammer and a screwdriver? Of course. Angela, you had an idea? Go ahead.
I would say factor.
Okay, what would you like to do first? Be specific.
Factor out 2.
Good. What's that called? What process are you doing? Well, it's okay. You don't have to know the name. You know the process. Milan, you know the name? Yeah, she's doing a GCF. So you want to factor out a 2 because all these numbers have a 2 in common. We could do one better. What would be an even better number to factor out, Aaron? A negative 2. That would help us get rid of this negative sign right here and make our lives a little bit easier. So we could rewrite this as 0 equals negative 2 times whatever's left over. Negative 2 times positive 8, negative 2 times negative 15, and negative 2 times positive 9. Very nicely done. So we used one tool, factoring. A subtool was greatest common factor. It's kind of like, I need a screwdriver. Oh, but wait, which screwdriver? Do I need a flathead or do I need a Phillips head? Do I need a little tiny thin one or do I need one of the big giant ones? So every tool has some subtools. But we're still not ready. We haven't solved yet. We haven't found what we want. What do we do with that? What do you think we should do? Go ahead. What do you think we should do? Sean, what do you think we should do?
Before you call on me, I'm not the words I don't know.
Good. But you have a certain number of choices, right? What are the choices we have?
What's
You don't know what choices we have?
some of them.
Tell me one of them.
Quadratic form.
Beautiful. Can we do it? Can we use that tool right now? Too much pressure? Okay, I apologize. There's no pressure. It's a simple question. Can we use the tool now if we wanted to?
Yes.
Yes, we can, because this has an A, a B, and a C. If it's got A, B, C, we can do it. The question is there a better tool to use before we use it? Anyone have a thought? Better tool? We could try doing the trick, but the first step of the trick is doing A times C, and you end up with 72. Once the number gets to be a certain greater than a certain value, the trick starts to become really hard. Because there's lots of factors of 72, and you don't want to have to go through all of them. So at this point, the best tool is probably the quadratic formula. So nicely done. So let's go ahead and use the quadratic formula. X equals negative b, opposite of b, plus or minus the square root of b squared. You're supposed to know that off the top of your head. Who knows it? 15 squared. Oh, come on. Angela?
225.
It is 225. Negative 15 squared, of course, would also be 225. Minus 4 times A times C. The whole thing over 2A, which is 8, and so that's going to be a 16. So the first thing to crank out is this part in here. So go ahead and focus on that. Go. What do we get for the result of doing 225 minus 4 times 8 times 9? What do we get? I should have asked it differently. Give me a thumbs up if you've got the result. I got 1 person, 2 people, 3, 4 people. Okay, I apologize. Take another 5 people, 6 people. Okay, put your thumbs down. 7 people. So Daniela, for the highlighted part, what is the result? Negative. This is a negative 63. We sure? Let's see. 4 negative times 8 is negative 32 times 9 is negative 288. And if we add 225, well, look at that. We got negative 63. So now we need to take the square root of that. So everyone in your calculator put a negative 63, take the square root. Diane? Error? Did everyone get an error?
Yeah.
Oh. Well, what do we do now? What do we do now? We got an error. We got to do something. What'd you do? Break my calculator? What did you do now, Milan? That's right. So should you have even done it? No. But now what do? We have to answer the question. What was the question? So what's the answer to the question? Let's focus on finishing this out strong. What is the answer to the question? Melinda?
You will not reach 20
Yeah, that's pretty good.
Yeah.
Because when we tried to solve the quadratic, with the height, the ending height being 20, it didn't work. This cannot be done, which means there's no solution, no real solution. And since there's no solution, that means that, listen to this is the key part. I actually should not have put an X, I should have put a T, so I apologize for that. This is really T equals and T equals because in the formula, this is a T. T stands for what? Time. What that means is at no time, there's no time that we can find where this object is at 20 feet. There's no point in time when the object is at 20 feet. Since there's no point in time when that happens, the answer is no. It will not reach a height of 20 feet. So, Melinda, you were absolutely correct. The answer is no. It was an actual yes or no question, but it's not a guessing game. This is all the work that supports this answer. Any concerns, any questions, any thoughts about what we did here? You guys did quite well. Checkpoint number 3. It's a team challenge. The team challenge is this. I am giving you one equation to solve. But as a team, you must solve it 3 ways. You must solve it 3 different ways. And each member of the group, of the team, does one method. You're going to have to fight with each other. Okay, no fight. You're going to have to discuss with each other who's going to do which method. I'm going to leave it up to you. Hold on. We're not ready yet. Don't start scrapping yet. Then, when you are all done finding the solutions, you're going to compare your answers and then discuss which method was the most efficient. We're going to do 2 things when we're done. We're going to get the solutions, the correct solutions, and then I'm going to survey the class and find out which method you thought was the most efficient for this situation. Anyone have any questions? All right, you got 5 minutes for the team challenge. Go.
Well, I think this one
I don't have no others on my team there, or I don't have teams. It's hard. Error. Incomplete. That's a team. It's not a team. She wanted to do the one-step formula. Look, it's way easier. You can. There's a trick. Oh my gosh. But you guys
times 20. Oh my god. Just in case I don't know.
That's right.
She just asked me what's 1 times 20.
Got 2.5 minutes to do it.
That's what I'm putting. I'm here to trick.
You can't spell that. You can't spell that either.
It's so complicated.
Okay, what method did you use? What method did you use?
I'm slow. We're gonna use the square root, but
That's correct. Okay, so pick a different method. What method are you doing? Good. Good. You're going to do another method. Pick one other method.
There's a graphic, right? There's only 1, 2, 3, 4.
You already done this? You can graph it also.
Isn't there only 4 and then there's supposed to be 5? How many methods do you type? Because you took out one of them, which you did my favorite.
yes.
Don't care. I'm gonna tell you something into the methods, but there's only 4 because there were 5.
You're going to do duplicate one of them.
Oh, okay, I understand.
So 9 plus 1 is 10, 10 5 by 2 is
What's 9 divided by 2?
Did you guys use another method? Okay, but that's why you method.
Oh yeah, you did right. You divided 6
I didn't ask you what you felt like doing.
But you got x equals what?
Sometimes when a team member does, you gotta figure this out.
Okay. I sure got me like
Oh yeah.
All right. Team challenge is over. Or I should say time is up. First I'm going to call on individuals. When I call on you, you tell me the solutions that you figured out. You tell me the solutions you figured out. All right. I've got student. 6 is up here. I got student 2, 12, 13, 17, and 18. Student number 2, what'd you get?
I didn't.
You didn't get any solutions at all. Because you didn't finish. Okay? Student number 12. Student number 13. Student number 17. Student number 18. That's a good thing because the solutions are 5 and 4. There were really only 3 methods that you could use. The 3 methods were graphing, factoring, and quadratic formula. You couldn't use square roots because there's a middle term. So here's what the work could have looked like. Here's the graph. Here is factoring. And here is the quadratic formula. So, the big question is, what did you find to be the most efficient? What was the most efficient? Now I'm going to call on a team. Make sure you know your team letter. Team F, Team A, and Team G. Team F, what did you say is the most efficient?
okay.
Team A, what do you say, Isabella? Team G, what did you guys come up with? You all thought factoring. Even looking at the amount of work involved, keeping in mind that I didn't even put up the table of values for the graph, The least amount of work is clearly this right here. But all of them get you the same result. Does anyone have any questions about this activity, this team challenge? Any questions? Good, you guys did quite well with it. I'm quite impressed. Your homework is on page 477. You're doing numbers 1 through 4 and 8 through 12. Make sure you copy that down. Please do not come in telling me you did the wrong questions. And then on page 478, you're doing numbers 1 and 4. That's a total of 11 questions. In Algebra Nation, you should definitely be up to section 5, if not beyond that.